All right, we are going to talk today about water as a polar molecule. I want to begin with the learning goal because remember, as we are going through this, you should be watching, listening, reading with your mind on, asking yourself, what am I supposed to learn from this? So, the state of Florida requires that all students can, as the learning goal states, discuss the special properties of water that make it so unique for life on Earth. And some of those properties include cohesive behavior, ability to moderate temperature, expands upon freezing, and its versatility as a solvent. This segment of the lecture series is just going to cover water as a polar molecule. It's this special chemical property that gives water all of its unique properties that allow it to be the essential liquid for life. We use that word polar. We've used it before when we describe the ends of the earth. And so I have put this picture on here so that you have a visual. So you can think, wait, when it says polars, we're talking about the ends of the molecule. Here I have a molecule of water and a molecule is shown on the screen. And I want you to look at the overall shape of this molecule. It is not in a straight line, but it is a curved molecule. And this is true to form. The shape of hydrogen and two hydrogens and one oxygen forming a chemical bond together is always in this shape. It always chemically bonds at this angular structure. You'll learn more about why that happens and the nature of how these two types of atoms chemically interact with one another in chemistry class if you choose to take that next year. But for this year in biology, what you need to make sure you remember is that water is not a linear molecule, it's always at an angle. So, looking at the screen, keep in mind that the formula for water is H2O. I know you saw that in the video, but I want to make sure I emphasize that. And that means it has one hydrogen, one oxygen, and two hydrogen molecules. You may notice that there are always, whenever you see a picture of water, these markings that one's a negative sign, one's a positive sign. We'll talk about that in just 1 second, but that's a hint as to the polar nature of water. Why is water not a straight line molecule? Why is it always angled? It has to do with the electrons and how oxygen atoms and hydrogen atoms share their electrons. On this illustration here, it shows you the electrons of oxygen, and remember, those are negatively charged. And inside of this center circle is the nucleus of the oxygen atom, which is where the protons are found, the positively charged protons. The same is true here for hydrogen. Here's where the electron for hydrogen is found. And here's where the proton for hydrogen is found in both hydrogen atoms. Well, when these two molecules share electrons with one another, they don't share the electrons equally. It all has to do with oxygen in its nucleus having 16 positively charged protons, and hydrogen in its nucleus only having one positively charged proton. And so you guys remember from earlier science classes, opposites attract. So these negatively charged electrons have more of an attraction to this big positive charged nucleus of oxygen, such that when hydrogen and oxygen share these electrons, they do not share them equally. And the electrons spend more time revolving around the nucleus of the oxygen atom than they do revolving around the nucleus of the hydrogen atom. So the overall effect of these electrons spending so much time around the oxygen end, since they're negatively charged, they bring a slightly negative charge to the oxygen end of the molecule. Since the electrons spend less time revolving around the hydrogen end of the water molecule, it leaves a slightly positive charge around each of the hydrogen ends. Now notice I'm using the word slightly. It is not all the way negative, meaning that the electrons never go to the hydrogen atoms, but it just gives it a slightly negative charge on one end, a slightly positive charge on the other end. So why is the water molecule not straight, or why is it polar? Why does it have two charges on the ends of each pole? Here is the reason. The electrons that are being shared between the oxygen and the hydrogen atoms are not being shared equally, and therefore the electrons spend more time around the oxygen end, giving it a slightly negative charge, and less time around the hydrogen ends, giving them a slightly positive charge. It's this unique property of water, molecular property of water, where one end is slightly negative and one end is slightly positive, that leads to all of the unique properties of water you saw in the video.